All right, so we are recording, and so we are doing a discussion, a lecture on Chapter 7, How to Handle Exceptions and Validate Data. We have all seen an exception in software before, whether you recognize it or not. When your program crashes, we've all used software that has crashed, right? You get a little error message, and then it goes away, and you got to reopen it, right? An exception is just a programming term for software that crashes, right? So when your software crashes, they say that an exception has occurred. And like out of the gate, I always talk about why is something important. And so when we're talking about handling exceptions, we're talking about preventing your software from crashing. What can you do as a programmer to prevent your software from crashing? And we learn an object-oriented approach at doing that, at doing just that, at stopping our programs from crashing. And so why is this important? Well, depending on the software, it might be critically important to someone's life, maybe, right? So I've had students, graduates, working on software that delivers like laser radiation kind of stuff to cancer patients. Chemotherapy kind of. Those lasers have to be delivered pretty precisely, and you can't have that software crashing, right? Because at the other end of that laser is someone's organ, and deliver that to the wrong spot, and you might kill somebody. Yes, people have died because of poorly coded software. Right? I've had graduates go work in some pretty critical fields. I've had other graduates, nowadays in COVID, everything's telehealth and telemedicine. And so now they have software that remotely monitor patients in the hospital. Right? And so nurses can be monitoring patients in other states and looking at vital signs. Right? That software needs to stay running pretty critically. Again, there's people's lives at the end of the software. You got to keep that running. Not only people's lives, of course, that's pretty obvious, but you could also say lots and lots of money. I've had students, graduates, who work, and if you've ever worked at like the Army and all this kind of stuff, they deal a lot with satellites. They go up in orbit, and these satellites, there's all these different satellites in orbit, and obviously those satellites cost a lot of money to launch into orbit, and then they're in orbit and they can't really crash into one another, right? Imagine how much money it takes to get a rocket up in the air, get a satellite into orbit, and then it's rotating around the Earth. You can't have these things crashing into one another. Right, so I've had students working on software that will tell these two satellites to alter their path so they avoid collisions, so they don't blow up in orbit. Yeah.
But coding stuff like that, will that start dealing with like physics?
Yeah, so you really got to understand. It's kind of like that math problem. You got two trains, and they're going this speed and that speed, and this path and that path. When do they collide? It's kind of like that. You got to understand some pretty good, math, physics, and that kind of stuff. Yeah.
It's interesting when you say that about the medical. 2 years ago, I was diagnosed with breast cancer. Knock on wood, all good now.
Nice.
But when we were setting up for radiation, because I just had to think it was only radiation. The hard part was getting me on that table and exactly where the cancer was. They knew, and it took longer for them to set me up. And here were these, and you were talking about those, the line. I mean, you could see the I guess what is it?
Lasers or whatever
the
they are.
lasers.
Yeah.
and they were absolutely precise, and it took longer for them to get it set up
Hmm.
than it did to do the whole thing.
Mm-hmm.
And it was real interesting, because my last one, my husband Tim was there, and he says, "Oh, can I push the buttons?" Or like, "No, no, no, no," you know, because it was, I never realized until he just said this, that it was a program.
Yeah.
And it was, and it was interesting, because the door, Incitement Center was like this thick, because it was radiation, but it was so precise
Yeah.
that it's not even, it didn't make me sick or anything.
Yeah. Real life case.
I
Yeah.
never thought about that.
Yeah. On the other hand, on the other side of the equation, okay, I've had graduates go work for companies, and the one that comes to mind is the post office. And so I've had a graduate go work for the post office, writing software for the post office, and they did not handle their exceptions at all. If their software would crash, it was no big deal, just relaunch it and run it again. And yeah, that kind of, I saw a couple faces, which is like, really? Why would you do that? It's just not, it wasn't, I guess the idea is it wasn't a mission critical thing to keep running. The software crashed, you started it back up, and you did your search again, right? I mean, is it super critical if your Spotify crashes and you got to start the song over?
Yes.
Probably not as critical as someone's life or billions of dollars, right? So some software, interestingly enough, they just kind of like let it crash and let it start back over. Because, well, why would that be? Like, well, handling exceptions is actually a little bit what I would call expensive in the software development world. And what I mean by expensive, again, take it back when I was first doing it. I remember this. I'm writing software, be it 25 years ago, and I'm on a computer from 25 years ago. And I'm like learning and writing software for the first time. And what we're going to learn here is something called a try-catch block. So we're going to learn this try-catch block. And I'm writing a try-catch block for the first time on this computer that's 25 years old. And it was a fast computer for its time. But I remember writing this code, and all of a sudden, I clicked a button, and I'm just kind of sitting there waiting. And I'm like, normally my computer responds faster, and I kind of like wiggled the mouse a little bit, and it was like not responding kind of thing. Like it was noticeably slowing my program down. So I learned pretty quickly that there was a little bit of a cost to performance. It's a high cost to performance. Now today's computers are much, much faster. It's not as obvious. You don't really see it as obviously, but there is a little bit of a performance cost with this. Okay, these try-catch blocks. Again, you don't really see it in today's computers because things are so doggone fast, but I remember that experience from 25 years ago, that the post office might say, well, instead of slowing down our computer, our software, instead of slowing down our computer, filling it with these try-catch blocks, now, ultimately, what do I want you to take away from this? Exceptions crash your program. Sometimes it's just okay to crash. Sometimes you don't want your programs to crash. It's not always going to be your decision on whether it's okay or not. It's probably someone else's decision. Like I said, graduate works at the post office. They're going to tell you, no try catches. We're not going to handle exceptions. And that was the decision that the business makers made. Sometimes you go work for more mission critical software where you got lots of money on the line or people's lives on the line. It's okay if the software runs slower, you just don't want someone to die, kind of thing. And so that's what exceptions are. That's why they are important. Again, always talk about the why. I actually like this one because the why is a little bit different. For the last 5 chapters, the why has always been the same. Code reusability, code reusability, code reusability. right? I've been up here preaching about code reusability for many chapters now, for like at least a month. And this one's a little bit different. The why behind this is a little bit different. Now, it says how to handle exceptions and validate data. You know, we've been doing data validations already. You know, if a user enters a negative number, prompt them again for a positive number, right? Until loop, and continually ask the user for a positive number. That is data validation. We've been doing things like for loops and if statements to validate data. That's what the post office did. They just used for loops and if statements and try parses, right, to validate data, to get good data from the user. So it kind of breaks down. You've got exception handling versus traditional error handling. And they're kind of for validation. So when it comes to like, or a bunch of other things, if it comes down to, again, you're working at the post office and you don't want to put in try-catch blocks, you're just kind of left with your other tools in your toolbox, like if statements and for loops and the like. Okay? But a lot of times these two things can, in many cases, do a lot of similar functionality. They can both achieve the result. So when do you use one versus when do you use the other? When's it appropriate to use exception handling versus when do you use if statements and the like with loops? Okay? It is worth noting that exception handling is known as an object-oriented approach, right? So since we're studying C#, which is an object-oriented language, you know, these try-catch blocks are working with objects. Okay, so other languages, maybe not all languages that aren't object-oriented, you know, have this in C#, this object-oriented approach at solving these things. Now, you've seen exception handling, and this is just kind of a screenshot of an exception that has occurred in running your software. If you paid close attention and you read your error message, it even says exception in this error message. If you guys can kind of see that, it says system format exception input string was not in the correct format. So from those of you who have been doing this, what is this error telling us?
Not convert string to decimal.
Yeah. So we've got a text box here called monthly investment. The user probably typed in a letter or a symbol or something that could not be converted into a decimal data type. That crashes your program, right? So a little bit of data validation could be done to make sure that information that they give you, that the user's information that they give you can be converted into a decimal. Now, what's the method that we learned that will try to convert, and if it doesn't convert, it'll assign a 0 instead? Try parse. Right? So one thing that we learned in this class is that, hey, if I don't want this format exception to come up here, there are other techniques. There's the decimal.tryparse. And decimal tryparse is one way of working around this. But the point that's worth making here is that this is one kind of exception. There are many kinds of exceptions. And because this is an object-oriented approach, you could see an exception hierarchy. Oh, because we had to study inheritance first, and we know that in inheritance, you've got classes that inherit from parents, that inherit from parents, inherit from parents. And so you go up the inheritance chain, you get more generic, and you go down the inheritance chain, you get more specific. So like we might have one class called exception. It's kind of like the root class. And then underneath exception, we might have format exception. That's just what we just saw, a format exception. Trying to convert something into a decimal and it doesn't work. That's a format exception. You might have something like an arithmetic exception. Underneath arithmetic, you might, at some point, try to divide by 0. Trying to divide by 0 can't be done, therefore crashes your software. You get a divide by 0 exception. Maybe an overflow exception. An overflow exception is like, hey, I've got an array with 10 units and I'm trying to put 11 things into it. Like you're putting 11 items into a 10 storage unit container. Doesn't fit. That's going to overflow. Or, hey, I've got this data type like a byte. A byte can store whole numbers between 0 and 255. You got a range, and I'm trying to store some big number like 1,000 inside of a small data type, right? It might overflow the data type. And so you kind of see here some different exceptions that can be thrown by various methods. Okay, so we've got convert to decimal, can throw a format exception or an overflow exception. Because again, you might not be able to store some numbers inside of a decimal. Again, if we're trying to parse something into a date time, if that parse method is unable to convert that string into a date time object, you're going to get a format exception. So, it's also just kind of worth maybe Google searching like C# exception classes. And of course, kind of hitting the Microsoft Docs. And they right away, they kind of show you a divide by 0 exception. And they show you an example of it. Here we've got an integer x. Here, that line, be it right here that I'm going to highlight, would crash your program 100% of the time. When it runs that line, your program would crash. The user would get an unfriendly error message saying divide by 0 exception. Like most end users are going to go, I don't know what happened, it just crashed. And so it's actually not hard to prevent the software from crashing when you know the problem, right? When you know the problem, it tells you the problem when the software crashes. It says format, by 0 or divide by 0. So what you do is you wrap the culprit. What line of code is causing the exception? It will tell you line 50, line 30, unhandled exception. When an exception is quote unquote unhandled, that means it crashed your program. An unhandled exception crashes your program. It says line number whatever. You know the exception type and you know what line number. So what you do is you wrap that line, you wrap the culprit in a try block. And then in the catch block, notice the syntax for the catch block, it catches the type arithmetic exception. Well, why does it catch arithmetic exception? This is a divide by 0 exception. Well, you could catch a divide by 0 exception here. This line that I have highlighted, it could say divide by 0, and that would absolutely work. But we also learned that your objects could be upcasted, right? And since divide by 0 inherits from arithmetic, that's a valid upcast. And what does it do instead? Well, instead of crashing your program, it runs this line right here. So it runs the code in your catch block, whatever that code needs to do, and then it doesn't crash. Your software keeps running. So try catch blocks are actually pretty simple to implement. You wrap the culprit in a try block, and then you say, okay, when the exception occurs, run this code in the catch block instead, and then continue running your software. Now, it's also worth noting here, you can have multiple catch blocks because remember, one line of code can actually cause multiple exceptions. You run the software one time, it causes this exception. You run the software again, it causes a different exception. So because any given line can potentially throw multiple exceptions, you might need multiple catch blocks to catch the different exceptions that could be thrown. And so what you get here, what's a normal thing? A normal thing to have a catch block is to kind of save the problem to a log, right? So there's a problem in the code, right? It instead of crashing your software, you're going to notify somebody. You're going to let them know, hey, this scenario happened in this code. Bless you.
Bless you.
And instead of crashing your software, you just you log it. You log the problem. So Microsoft Windows has a log. There's an event log, there's an application log, there's a system log. And so, you might put it into an event log. You might save it to a database. You might save your errors to a database. And then what an application developer could do is they could say, oh my gosh, this exception is happening all the time in my code. How do I want to handle that? Do I want to write different code to fix that problem any differently? The other thing I want to point out here, again, kind of going back to this hierarchy, the exception class is a very general class. That's why it's high in the hierarchy. Right? The lower in the hierarchy you go, the more specific you get. Take a look at these two catch blocks. Because a try block can have multiple catch blocks, and your exception objects can be upcasted, it's important in the order of your catch blocks. Your catch blocks order is important. And they have to go kind of the opposite. Instead of general up top to specific down below, they have to go specific up top, down more general down below. Right? That will prevent upcasting from happening. Like, for example, if my first catch block was exception E, you could have 50 different exceptions that all need to be handled differently, but that exception block would catch all of them. Yeah.
Kind of like an FL.
Yeah, like in FL. It's like you wanna. It's only gonna run one of those branches, and so because this is only gonna run this branch or that branch, you have to code it in an order to run the right code first. Okay. So again, kind of rule of thumb here: you put the culprit, the problem code inside of a try block. You can have multiple lines of code inside of a try block. Like I could put 50 lines of code inside of a try. You can say, okay, any exceptions that happen inside this. So then the question becomes, well, why don't I just wrap everything in one giant try block? Again, remember, there's a performance hit here, right? There's a performance cost. So, you don't really see that, like one giant try block around all of your software, I believe for that reason, right? I don't really know any other reason why not, right? But then also it's just better practice to know what lines of code would be causing your exception and just saying, okay, well, in this line of code, that might throw an arithmetic exception. So just kind of, it's more, addressing the problem of that line of code. To go back, I'm kind of interested, C# exception hierarchy. hierarchy. So you kind of go, remember object, if you're just glancing at this, object is the class on top of all other classes. Underneath that, you'll find exception. Underneath that, there's two branches. You've got system exception and application exception. Broadly speaking, we deal with system exceptions. We don't deal a lot with application exceptions. Application exceptions, you see everything that we don't look really underneath the application exceptions. Those are more like hardware related exceptions. They're a little bit out of the software developer's control. Okay, I'll give you an example of this, and if you're old enough, you remember in the old days, you know, I would get often, and maybe you guys remember this, I would run software on my old computer, and the software would crash and your system would say out of RAM. Like your software, you just try and open like two different programs at once, and that was too taxing on your computer, and your random access memory was very limited. It was a limited resource, and you ran out of it, and then it would have to close one. It'd have to shut one down. And the software developer wouldn't have any control over that, right? So that kind of hardware problem, running out of RAM, running out of hard drive space, you know, hardware malfunctioning, generally speaking, falls under that other branch, that application exception. Okay, so we don't handle that. And I guess at the end of the day, there's probably no way to keep all software running 100% of the time for those kinds of reasons. Right? I mean, at the end of the day, if someone unplugs the power of your computer, guess what? That thing's going down, you know? So there will be hardware problems that you're out of your control. But what we're learning are, okay, if I coded some software that's crashing my program, how can I instead keep that running? Generally speaking, everything will be under the system exception branch.
You would think it'd be the other way around.
You kind of would, wouldn't you? So the next thing to kind of say is, well, what are all the different classes that are out there? Like here we get overflow exception, and we call divide by zero exception, right? Those are two classes: format exception, overflow exception. And it's kind of like this. The longer you're a C# developer, I mean, there are hundreds of exception classes, and they all kind of handle different scenarios. So, you know, you'll get familiarized with maybe 5, 10 of them, 15 of them in this chapter. Like you'll get exposure to them and how exceptions work. And then the longer, if you do become a C# developer, the longer you're working with the C# library, you'll gain more and more exposure. Yeah.
So like so the try catch, for example, is if there's an exception, like I've seen it multiple times, like where it just crashes and says exception unhandled, and
Yes.
it also gives you like multiple like check marks.
Yep.
So like you put them basically just like if you're trying to loop, you put them into a property. That's what would help it.
You put that into a try block.
Is
and
it
then,
every one of them into a try block, like every like sort of exception, or is it like are there different like?
Well, so if you hit an exception and it gives you that type of exception, you would just handle that one. Yeah, you would just handle that one. Now take a little bit of a closer look at this block of code. Notice what we have right here. Inside the catch block is a set of parentheses. We've got a variable, right? This variable, the identifier, is just called EX, and that's just a convention, right? The variable identifier, this is an exception, so call the exception EX. Okay, I understand that. The data type of our variable is a class. The class is the exception class. And because it's a class, you've got methods and you've got properties. So built into the exception class, there's kind of a default message. There's a default, remember the get type? Get type is going to tell you that this is the exception class. There's something called a stack trace. The stack trace is a really important piece of data because it tells you, hey, not only did line 50 throw this exception, but the reason line 50 is executing is because method A called method B called method C called method D. That's why line 50 is running in the first place. So the stack trace, again, this is important to understand. Why is line 50 even running? If Nathan wrote a bunch of software and I'm trying to fix a problem, and it is crashing on line 50, I need to know why line 50 is running in the first place. I need to understand Hansel and Gretel, right? Get your way through the woods. Why is line 50 running? Well, because this happened, and that happened, and that happened, and that happened, right? These different method calls. All those method calls are found in the stack trace.
Kind of like when you debug the program in Visual Studio.
Yeah, it'll tell you, line 50, this method was called, line 60, that method was called. It will give you the method by method, what methods were called to execute that line of code. So again, these are properties of an exception object and methods of an exception object that you can leverage to give some error messages. Now, at the end of the day, if you prevent your software from crashing, you just want to give your users kind of a friendly error message. I don't know that you want to put the type like this to me probably at the end of the day isn't a very user-friendly error message. Right? So if you if the software is crashing, you stop it from crashing, you want to give the users a friendly error message. Hey, don't give me that data the way you gave me that data. Try again. Okay? And then what you could do is you could take the technical message and the technical data type and the technical stack trace and save that for a developer's eyes. Right? So my point here is that this object has methods and properties that are more meant for developers' eyes as opposed to end users' eyes. Because end users are going to go, I don't know what exception class is. Why are you telling me that there's a type exception? What are you talking about? Right? End users don't understand that. Okay, so as we resume from a little bit of a break, we left off here on slide 13, which really just has one new piece of information on it. And so I've talked about the try statements, the try block of code, then these different optional catches from most specific at the top to most generic at the bottom. And there's something new here called the finally block. The finally block is an interesting block of code that you'll often hear, the purpose of the finally block is often referred to as like cleanup tasks. And so the way the finally block works is this, and then I'll explain cleanup tasks. Finally block will run regardless if a try block throws an exception or not. So if an exception occurs, the finally block will run. If an exception does not occur, the finally block will run. If an exception occurs in the try block, it could potentially be caught, or it could also not be caught, right? If you don't catch your exception, that's your unhandled exception that crashes your program. So a finally block just kind of runs regardless of an exception occurring or not, and whether that exception is caught or not. And so the reason that's kind of the theory behind finally, and then The reason they often refer to it as cleanup tasks is you want to put code in there. For example, if you open a connection to a file or to a database, you want to open a connection. You want to make sure that that connection is closed properly, right? So if you open up a connection to a database, you don't want to leave that connection open because databases can have only so many open connections at a time. You want to make sure to close it. So a lot of times you put that kind of code in the finally block. That way, if an exception occurs, your program crashes, the finally block before your program's taken, before it crashes and stops running, it's going to close that connection to the database. Again, regardless of that exception being caught or not being caught, doesn't really matter. So that's the theory behind finally. It's often, again, like I said, cleanup tasks. You open a file, you close a file. You open a connection to a database, you close a connection to a database. Things that you open, you often want to close inside of finally. And so very generically speaking here, you're wrapping a bunch of statements in a try, you got a bunch of different catch blocks, and then in a finally, they just have a method call that says perform cleanup. Again, close your connections, whatever it may be. One last thing that I realized I didn't cover up until this point is at the beginning, I mentioned this idea of, do you handle your exceptions with exception handling, which is an object-oriented approach, or traditional error handling, which is just like if statements and loops. And I did say that it's oftentimes like the business will decide that for you on whether you will do one or the other, or a combination of both. If you're going to do, sometimes you do exception handling, try catches, other times you use if statements. There's another rule of thumb that I didn't cover with you guys that says something like this, and again, this is just broad rules of thumb. This isn't every case. Is that an exception should I don't like when you use a word to define it. There's that old English, like never use in the definition of a word, the word itself. But I'm going to kind of do a little bit of that here. Exceptions should occur as the exception to the rule, meaning if something happens often, it's not an exception. If something happens often and is crashing your program often, you probably want to use traditional error handling, right? So since exceptions should occur as the exception to the rule, it should be infrequent. So exception handling should handle errors that occur infrequently. If it's a frequent error that's happening often, you should be more inclined to use traditional error handling approaches, loops, and if statements. Okay, but if you run this line of code 1,000 times and an exception occurs 5 times, that's the exception to the rule, not the normal. Right? So a rule of thumb, this is just a rule. This is a general rule of thumb, right? AKA less than 10% of the time. If you run your program a lot and this exception is occurring very infrequently, you could consider using a try-catch block. Like if you're the decision maker on how you handle exceptions, right? But if your end users are running the software and this exception is happening a lot, you should use more of a traditional error handling approach, right? So rule number 1, your business might make these decisions for you, but if you have to decide and you decide, you know what, I want to use a little bit of exception handling and a little bit of traditional error handling, the rule of thumb is that, hey, if it's happening a lot, use traditional error handling. If it's happening infrequently, something like less than 10%, maybe, maybe less than 5%. Again, this is just kind of a general guideline, not a hard rule around this. Now, exceptions can kind of occur naturally just by writing code and running code. Okay, exceptions can occur naturally, but there can also be conditions. Again, if this is an error message that happens infrequently, right? Again, you can kind of decide: do I want to handle that with an if-else statement in a loop? Or do I want something more severe to happen? Like, I do not want in my bank account software, under any circumstance, I do not want to allow a negative balance. And you know what? If a user tries to do a negative balance, I'm just going to crash my software. Like that is the consequence. I'm not going to allow it. Right? So you can define conditions that you might want to manually generate an exception, because you're not going to allow this in your software. Again, it should happen infrequently, but it can be the case. So there are built-in exception classes, but because we know how inheritance works, at least we have an idea now how inheritance works, we can make our own. We can make our own exception classes. And say, you know what, if this condition in my software were to occur, I want to make sure that I handle this problem, and if I don't handle this problem, it would actually crash my software instead of allowing this problem to occur. Right? So it would have to be a severe consequence, like I'm not going to allow just making something up here. So the syntax for generating your own exception is this throw new. Right? When I say throw new and then the name of your exception, that is manually what is called firing an exception. You're firing an exception. You're causing an exception to occur. And then if you don't handle that exception, it will crash your program. Of course, how do you handle an exception? You wrap it in a try-catch block. Right, so just to kind of quickly maybe just demonstrate this, right? It's a pretty simple little line of code. Bank account demo. And again, I'm just going to kind of spin this up real quick and show how you can make your own exception class and how you could cause that exception class to run. Again, the theory there is that this is a severe consequence that you do not want to allow in your code from happening. And if this condition were to hit, you would rather crash your software than allow that condition to take place. So you want to make sure that you're handling that condition. You're going to force someone to handle that condition. So in my simple example, let's make a class called negative balance. So negative balance exception. I'll just call it negative balance.cs. And there's a debate about the appropriate class to inherit from. You can inherit from exception. You can inherit from system exception. There's different classes, but we know that exception is kind of like the parent class of all of them. I'm going to mark this as public and public negative balance string message. we're going to say colon base, pass the message up. Wait a sec, I did that at the wrong spot. Let's do that right here. Okay, so when we create an instance of this class, now this is an exception class. Again, we covered the theory on why you would generate your own exception class. Built-in exception classes, making your own exception classes. We just made our own. Let me just quickly demonstrate how to throw that exception class. So of course we're going to have a button click. All right, generate negative balance button. So we don't generate it like I was about to start, you know, like this, new negative balance. Okay, instead we're just going to throw a new negative balance exception. It's going to say balance can't be negative. So again, we've created our own exception class. That exception class inherits from exception. We allow the constructor to take in a string message, and we just pass that message up to the parent constructor, which is exception. So we're just going to kind of pass the exception message right on up. And when we run this, it's going to crash our program. Again, we're just not going to allow a negative balance. And so ultimately, bank account demo, it's really not going to be anything crazy impressive, because it's just going to crash. So there's that, and there it goes. Unhandled exception has occurred, and there's your message, balance can't be negative. So the message I gave it in the constructor shows up right there, unhandled exception. So how do I handle it? Well, this is kind of where it gets interesting. You might say, well, why would you do this? There's a lot of, I understand that logic, like, hey, I'm going to throw an exception, and I'm going to catch negative balance EX and message box dot show EX dot message. Now this is doing the same thing, except for this is actually not crashing the program, even though you just get the same message. It says balance can't be negative. This demonstrates a try-catch block working. This demonstrates, hey, our program's not crashing. Okay, so even though the end result's like, okay, it looks basically the same, it's not, because realize our program's not crashing. We handled the exception here. And there's one interesting kind of concept that if I don't put my try-catch here, well, how would we actually do this? Probably in a real piece of software, we would have a class called bank account. So check this out. This is going to be useful for your lab. So if you guys are, I know it's been a long one, but you know, I'm going to add a class called bank account, or just called account, right? And you've done this. You've had an account, and your account has some properties, you know, like an ID property, an account holder's name, and a balance. Now we're going to have some rules around our balance, so I'll go ahead and make an instance field underscore balance. And let's have a set block and a get block. And now notice my set block, I'll say if value is less than 0, this is our problem. And so how do we handle our problem? Well, because we're making the software, we get to decide. Do I just give them, do I handle it with if-else statements and loops and things of that nature? Or do I want a more severe consequence like an exception? Well, I just want to make sure that we're not doing this, and I'm going to decide to handle this as an exception because I don't expect negative balances often. I expect them very infrequently. It's the exception to the rule. I'm going to throw a new negative balance exception. Negative balances not allowed. And then what I'll do is I'll set the balance equal to 0. Okay, and if I get, I'll just say return underscore balance. Now the problem is we'll set the balance first before we throw the exception. That was giving me a little green squiggly, probably because it was throwing the exception before we were setting the balance, and so probably the program could crash here and then never set the balance. This concept is something you guys will need for your labs if you're asked to manually throw your own exception like I'm doing here. Instead of putting your try catch right here, okay, the real world scenario is that software is a collaborative effort. It's not one person writes all the software. And so we might have a business rule that doesn't allow negative balances. I might make this class, and then you're going to be the user of the class, right? Another developer on my team is actually going to implement an account object, right? So I might make the class, but then someone else might actually use the account object. So what you do is you let the user of your class decide how they're going to handle the exception, or if they're going to handle it or not. And so this exception is going to be thrown inside of this set block, and then the user of the class will decide if they handle the exception or not. And so it just kind of boils down to, now that we have a negative balance, let's make an account A1 equals new account. And I'm going to set the balance equal to negative 123. I'll set the name equal to Gudmested and the ID equal to 1. Now, this line of code right here is obviously setting a negative balance. That line of code can potentially throw an exception. So then the user of my class, in other words, some other developer who's coding an account object, they will decide whether they let that crash their program, right, like that, or whether they wrap this line of code into try catch and negative balance EX, and I would just, do a little message box dot show ex.message plus balance cannot be negative, something like that. It's a little pop-up. I think it'll give you the same message. Try negative balance should not allow, balance cannot be negative.
So it didn't throw the error that you had in the class?
It threw the error. It threw the exception. The exception was thrown, but what that just happened is that's called bubbling up. Right? The exception bubbled up because the exception was not caught inside of this block of code. It bubbled up to this line where it was then caught. Right? Because you're calling that line of code right here. Right? So exceptions can bubble up and be caught by other methods that call that method. So if I even go back to here, think about it back here. Convert to decimal. Inside of this convert to decimal, someone is throwing an exception. And it's up to you to catch that exception. right? One person got it. So when you're coding your own classes, you can throw exceptions and let someone else decide if they catch it. This is the last thing, and then you guys are kind of wearing down. I see it. That's okay. It's been a long one. This double question mark operator, we haven't really talked about it much. I just want to briefly talk about it here. The way this works is, and I believe it's called the null coalescing operator. Who cares what it's called, but here's how it works. We create a variable called code, and we assign it to the value of product code. If product code has a value, then code equals product code. But notice product code is nullable. Product code is nullable, so there's a chance that product code is null. If product code is null, it doesn't assign code equal to product code. You know, it assigns code equal to what's on the right-hand side of these double question marks. So it's kind of like an if-else. Like, if product code is null, is not null, then assign code equal to product code, else assign it equal to this. So these double question marks, this is a kind of a newer C# syntax that I'm starting to see more and more of.
Is it placed within the class or is it placed within the form?
Either way.
Either way.
All right. We've covered a fair bit of theory on try-catch blocks. Not done lecturing on it, obviously, but that's enough to get you guys started. Okay, so I'll close the PowerPoint where I am. Stop the lecture.